You could do like,
Okay, so as I mentioned, we're going to take a break from testing today just because I don't want to kill off fry the brains of the PSAT. That was probably a number of you. So what I want to do instead, we're going to go ahead and start. We're going to start on our first new material. We're going to start on Unit 2, and we're out of the review now. I will leave the review open because it's review. It's a lot of information. I'm okay doing this. I'm going to leave the review tests and assignments open for 1 month. You got a month to do retakes, to use your retakes, to finish up assignments. After a month, it all, then it goes off limits. Okay? But you can kind of be working on that stuff on the side if you want to. Okay. But what you don't want to do, and I can't emphasize this enough, this is a big deal. The new material, you can't get behind on new material. Algebra 2 is super sequential, meaning you have to have step 1 to get step 2. Right? So throughout the class, when we get into Unit 3, it assumes you understand Unit 2. If you don't understand Unit 2 well, you got behind in Unit 2, you can see how that can snowball pretty quick. Right? Okay? So, let's look at this. This unit involves solving quadratic equations. So first of all, that's our unit that we're dealing with. So that's big picture. Okay, and today, we're just going to talk about how we solve kind of simple ones. Okay, how we can solve quadratic equations using the square root property. So later on, we're going to get into some harder quadratic equations that we can't solve using the square root property. But before we do anything on this, why is that new equation? This should look different than the stuff we've been working on during the review. During the review unit, we solved equations, but they were always linear equations. If we had graphed them, they always would have ended up being lines. This is different. What looks different about this one? Well, okay, that part, you still might have had that, but there's something really different here. Exponent, there you go. The exponent. The fact that you're taking an x squared. So if you've got x squareds in your equation instead of just x's, for now, later on I'll give you a much more precise definition when we get into Unit 3. But for now, that's what we mean by a quadratic equation. An equation where we have if our variable is x, where we've got x squares in addition to possibly x's, right? Okay, now what about this example though? This one, quadratic equations are definitely a big step up from linear equations. Right? This unit is, it's higher level algebra. A lot of it's going to be review. You will have done a lot of this in Algebra 1. But a good portion of it will be new or improved. Okay? We could solve this one though right now. I don't really have to show you anything. Okay, how come? Okay, with an added step. Yeah, so what's our strategy? In math, as you get further in math, it gets to be more and more about thinking before you do. Like when I teach, AP physics or my AP calculus class, the thing we end up talking about more than anything is how are you going to approach this problem? Problems get really big and ugly, and if you go down the wrong path, they can take a long time. And the phone should be away, please. Like away, like in your pockets away. I want to see them out. When we're doing this stuff, I'm pretty laid back guy. When I'm doing this stuff, I don't want any distractions with it. I lost my train of thought. What was I saying? In calculus, the problems can get really difficult. And if you don't spend some time up front thinking about, what's my strategy for doing this problem, you could take a wrong path. It could take 50 pages of math, when otherwise you could do it in 1 page of math, right? Same thing here. We always want to think about this in terms of a strategy, and then we'll do the algebra to use that strategy. So looking at this problem, I'm just going to rewrite it. Does anybody have any suggestions about what our strategy might be? Okay, subtract 36, and then divide by -4, and then square root. So you got it. So you already know this, right? How do you know those steps? Well, you've done enough algebra that in most cases you probably just, it's intuitive. You just know what to do. But if you don't, or as we move into future harder topics, you can always go back to the good old order of operations tree. It tells you, right? What did we say earlier in the year? If you can point to a single variable, which we can, right there, right? If you can point to a single variable, then you can isolate it by reversing order of operations, okay? There are some functions we're going to deal with that are sort of weird. Piecewise functions and absolute values and things like that, where we got to be, there's maybe some additional steps there. And I'll explain why when we get there. But for normal functions, like this, if you can point to a single x, you can isolate it. So what would the steps be? Well, we start at, oh, by the way, what's that P stand for? Okay, so if there are parentheses, we don't get there to the parentheses until the very last step, right? So addition, subtraction. You told me, first thing you said was subtract 36, and that's right. Okay, so that gives us negative 4x squared equals what? Negative 576. Good. Okay, step 1. Step 2. Okay, multiply, divide, so we're going to divide both sides by -4, right? Because our goal is just to get that x all by itself. Okay, so far so good. So -5, what's negative divided by negative? Positive. 576 divided by 4. Well, what's 5 divided by 4? 1, with 1 left over. 17 divided by 4 is 4, right? With how many left over? So 144? Everybody good? Okay. Last step. Okay, and that comes under exponents, right? Okay, so exponents, there's my exponent, and you guys know the drill, right? The drill is if you want to undo a squared, you just square root. I think that should work. Okay, so, what? No go?
No, we didn't click on this.
There we go. Okay, so I square root both sides. Good, so that's a piece of cake, right? We end up with x equals, and what's the square root of 144? 12. Oh, partially wrong. 12 is correct. Square root of 144 is 12. That's positive or negative. Very good. Okay. Okay, and that is what we call the square root property. That's it. The square root property says this. I'm going to write this down. Put this in your notes. The square root property says, if, I'm going to paraphrase this, and I'm not going to say it in super mathematical language because we don't need to. Make it simple. If you square root both sides of an equation, you must include plus or minus in your answer. Okay. How come? What numbers squared equal 144? 12 does. But what happens if I square a negative? It turns to a positive, right? So negative 12 would also work, wouldn't it? Make sense? So you just have to remember that. Later on in the class, I will prove that to you. But right now, we don't have the tools to do that. Later we will. Okay, but for now, we just have to accept that. That's what we call the square root property. And you can't forget that plus or minus, or you're missing solutions, right? There are two solutions to this one. So in Moodle, how would I enter this? Here's the answer box. What's it say? So find all real solutions of the equation below. Write your answers as exact solutions in simplified form. If multiple real solutions exist, separate them with commas. What do I do? Plus, there you go. 12, negative 12. Okay, how could I check these? Plug them in. I have to check them both. Okay. Make sense? Let's try another one. Okay, this one's a little easier, a little quicker. Oh, I guess not. Never mind. First step, subtract 14. Equals, what's that going to give me? Negative 100, right? Divide by 2, excellent. Okay, divide by 2. So I get last step, square root. Okay, so I get x equals plus or minus. I need by plus or minus, right? What's the square root of negative 50? Put that in your calculator real quick.
Doesn't work.
What's it say?
Doesn't work.
Doesn't work. How come?
Negative.
Ah, what's our rule? For real numbers, we said at the beginning of the year, we said there's two things you can't do with real numbers. You can't divide by
Zero.
You can't divide by 0, which we'll deal with a lot later in the class. And now we're getting into the other one. You can't take an even root. So for now, just a square root. Could be a 4th root or a 6th root. But square roots are examples. You can't take an even root of a negative number, right? So, yeah, so for now, if we look at because of this, it says if no real solutions exist, enter n. So in Moodle, now that's not some fancy n from the drop down, it's just a capital N, right? So I would just enter in Moodle, capital N. Okay, make sense? Later on, very soon, I mean like within a week, we'll be able to give a different kind of an answer that's not a real number, but actually is a numerical answer. That sounds strange probably, but you'll see. Okay? We're going to deal with some numbers that are not real numbers soon. Not today, though. Okay, so what about, let's do that like that one. Okay. All right, so this big ugly yellow thing here, let me just quickly, all this is saying is when you're inputting, this is the way it was last year, maybe Moodle's fixed this, I don't think they have probably. When you're putting in multiple solutions, because you're going to get from these, you're probably already seeing this trend, when you're solving a quadratic equation, you're going to get potentially more than one solution, right? So if you get a really complicated one, and this one's going to be a little bit more complicated, not terrible, this one will, later, like Monday, we'll get some harder stuff. If you try to cut and paste one answer to create another one, and then just edit it, that seems like a great idea, and I wish you could do it, but you can't. If you do that for some reason, it marks it wrong, even if it's right. So when you're putting in, like in this solving quadratic equation section, if you're putting in two answers that are very similar, but they're just slightly different, you actually have to type them all out, each one, which is a bummer, but you have to. You can try it, maybe they fixed it, and I can erase all these things. You can try it, but just know that it might trigger some weird error where you don't get it right. Okay? Inconvenient, but, oh well, we can live with it. So what are we going to do with this one? Okay, let me write it down here first. Okay, so raise your hand if you're going to say distribute. Oh, how come? Ah, very good. We can't. It seems like something that would be a great idea, but I can't distribute because this whole quantity is actually being squared. You can't distribute over a power, okay? And if you're wondering why, here's my best answer for now. My best answer for now is order of operations. So if I were going to simplify this, okay, that means I'm going down in this direction, right? I'm not isolating, but I'm just simplifying. Before I get to multiply, what would I have to do? I'd have to do the exponent. So I would have to take negative 5x plus 3
and square that whole thing, multiply it by itself before I could distribute. Does that make sense? So you can't distribute if there's a power over the quantity, okay? Very common mistake. We don't need to do that though. In fact, we don't want to do that. What we want to do is something different. What we want to do is isolate, right? When we isolate a variable, we just go bottom to top. How many x's are there in that equation? 1. It's right there. I can point to a single x, so I can isolate it, but I've got to very carefully follow the order of operations to get there. Now, notice you told me in the last example, what does that P stand for? Parentheses. Well, here are my parentheses, right? So everything in the parentheses is off limits until we get to that step, right? All of these other steps down here, they're referring to things that are being done outside of the parentheses. That make sense? Okay. So what is our first step going to be then? Add 5, because that 5 is outside of the parentheses. So step 1, add 5 to both sides. Okay, and that gives us -3 times the quantity -5x plus 3 squared equals what? -27. Okay, what's next? Okay, now we're going to multiply, divide. Well, notice that the -3 is outside of the parentheses. So we can divide both sides by -3, very good. And that gives us the quantity -5x plus 3 squared equals what? +9. Okay, now what? Okay, now the last part that's outside of the parentheses is the exponent, right? So next step would be, next step is going to be square rooting both sides to deal with that exponent. Okay, so I'll do that. The square root cancels the squared, right? That's the whole point. And I end up with -5x plus 3 equals, what's the square root of 9? 3. Okay, is that good?
No real solutions.
We made a mistake.
You have to move the other two.
What did we forget to do? What did we forget to do?
Shouldn't it be a positive sign?
No, because so we did the step of square rooting is fine, right? And I think I see what people are having a hard time with. They're having a hard time with the idea that I got this. Okay, I know what you're thinking right now, and I'm going to fix this. So if we have, okay, tell me if this isn't what you're concerned about. The square root of -5x plus 3. Didn't I just tell you you can't have a negative number? Okay, but here's the problem. The -5 is being multiplied by x, right?
You got to bring the, you gotta get that side itself.
You do, right. Okay, but let's just say, what if, like, we're trying to find x values that make this true. So if I were to put in an x value of 1, I would get -5 times 1 is -5 plus 3, that's -2. That's a problem. If I choose that x value, I'm getting a negative number under the square root, which is forbidden, right?
Could it be a negative x?
Okay, but what if x is a negative number, right? What if x was something like, for example, let's say x was, I'm trying to pick a good one. Well, let's just say it was -4, right? If I plug in -4 for x, I'm going to get -5 times -4 is what? 20 plus 3 is 23. Square root of 23 is okay, right? It's a weird number, but it's a number. You see my point? So we can have a negative coefficient under a radical. That's okay, right? That's okay because the value of the number that's inside the square root depends on what x is. And x could be lots of different things. It's a variable, right? So this is actually not a red flag for us. The fact that we have a -5x under our square root is okay. It's fine. Our job is to find the values of x that make the original equation true, right? So obviously we're only going to end up picking values of x that are going to work,
right? But the math gods will figure that out for us. We just have to follow the steps to get the x by itself. Okay, give me a thumbs up. That makes perfect sense. Sideways, so-so, means what? Okay. So let me say this one different way then. So in the process of solving this equation, the fact that I have a negative, that I have some expression involving x is in here that has a negative number in it, not a big deal. We don't care. Not a big deal. Our goal is to find the value of x that's going to work. And when all is said and done, the value of x that's going to work is guaranteed to be 1 if there is a value of x that works. We might find out there isn't, but if there is, the value or both values of x that work are guaranteed to be values that when I plug them in, give me a positive number under the radical. Okay? The math gods will figure that out on their own. So when we're done, we'll go back and kind of say, okay, I get it. No, that wasn't a big deal after. That x value works anyway. You'll see. So I did forget something, though. If I say it again. So when I square root both sides of an equation, what do I have to do? Plus or minus. Yeah, look at this. Here's an equation, and I square rooted both sides, so I have to get a plus or minus result. Okay? Everybody agree? Okay, so here's where we are. We actually have two answers coming here, don't we? Negative 5x plus 3 has to equal positive 3, or it has to equal negative 3. Okay? What are the steps going to be to get that x by itself? Subtract 3. Everybody agree?
Yeah.
Subtract 3. When I subtract 3, though, instead of putting plus or minus 3 minus 3, put this in your notes. This is a great little trick here. We're going to put the negative 3 on this side in front of the plus or minus. Okay, it's not like it's revolutionary, but it makes this whole process a little bit easier. So on the left side, I get a negative 5x. On the right side, I get negative 3 plus or minus 3. Okay, now let's go to the next page. I'm running out of room here. Okay, when I say plus or minus, the word or is in there. Or means we have two possible answers, both of which are okay, right? So negative 5x equals negative 3 or negative 3 plus 3 or negative 3 minus 3. If we take the plus sign, what's the result? Negative 3 plus 3 is 0. Agree? If I take the minus sign, I get negative 5x equals, what's negative 3 minus 3? Negative 6. Okay? I've just got two simple equations to solve now, right? What do I do over here? Divide by negative 5. Well, what's 0 divided by, who cares? 0. 0. There you go. Okay? Over here, we're going to divide both sides by negative 5 again. And we get x equals negative over negative is, and can I reduce 6/5? That's my answer. So those are my answers. Either x equals 0 or x equals negative 6/5.
Which one would you put in?
You put them both, because they're both going to work. Okay? And we can prove it. So if we go back to the original problem, so in Moodle, our answers would be, what do we have, 0 and 6/5?
Yeah. And negative 6.
I think it was positive. Negative over negative, yeah. Okay, so here's that little trick I showed you guys on graphing calculators. If we pull up a graphing calculator, here's how we can check this pretty easily. TI-84, you got it.
Okay, so if you got one of these fancy things, which you want to, here's how you can check this. So I'm gonna check the value 0. So I'm gonna type in a 0 and I'm gonna hit store as X and hit enter. So now every time I type an X and hit enter, I get 0. Okay? Big deal. Here's why I'm doing it. Now if I type in this expression, -3 times the quantity, -5x plus 3 squared minus 5, okay? Whatever's on the left side, if I plug in 0, what should I get? I better get -32 if it works, right? So if I hit enter, what do you know? I get -32 with 0 as my x value. So to check 6/5, all I'd have to do is 6 divided by 5, store x, 6/5, or I could use the little fancy fraction template if I want to. And I'm just going to go up and grab that same expression again and hit enter. I get -32. Okay? On Desmos, there's a really slick way to do this on Desmos also. Let me show you. So if you're using the non-graphing calculator, so the one you've been using, so this guy, oh man, come on, what did I just do? Okay, so what I could do here is every place I've got an x, I'm just going to put in like a 0 or a 6/5. Let's just do the one with the 6/5. So I could type out the expression. It's going to show up down here. How about if I scoot it up so you can see it better? Is that good? So I've got -3 times the quantity, so there's my parentheses, -5 times, well, I want to put in 6/5, right? So in parentheses, I'm just going to add a 6/5. And then I'll scoot over. So that's in place of my x, right? Then I add 3. And then I'm going to scoot over and I'm going to square the whole thing. And then I'm just going to subtract 5, right? What do I get? Okay. If I want to go try the other value in Desmos, all I got to do is just replace that 6/5 because that was my x value. I got to replace that with a 0, and I still get -32. Pretty good, right? Okay. I'll show you on the Desmos graphing calculator. I'll show you an even better way later. Okay, moving on. Oh, okay, so I want to show you one other thing on this. Yeah. So we know how to do it, but we could also, this is up to you. This is kind of an optional way you can do this. This is the way I would do it. This is the way I'm about to show you. The way we just showed you when we got to this point where we had some number plus or minus a number on the right side, we just said, okay, if we take the plus sign, what does that equation become? If I take the minus sign, what does that equation become? And solve them both. That's right. That's always going to work. Here's a little shortcut, though, if you're interested. Okay, I could actually just divide both sides through by -5, and it looks a little weird. What do I get? I get x equals -3 plus or minus 3 over -5. Okay? So if I take the plus, what does that become? If I take the plus, I just get -3 minus 3 is, or sorry, -3 plus 3 is 0 over -5, which is my 0. If I take the minus, I get -3 minus 3, over -5, which is -6 over -5, which is 6/5. Or you just write it as one big expression and either take the plus sign or the minus sign. Yep.
Can you always do it like that?
Yeah. You can. Yeah. Always do it like that. Okay? Make sense? All right. I think I'm good. I think once you guys try at least one of, there's 2 groups of problems on the 2.1 practice 1. Try one from each group. Okay? One from each group. And then if you got that, you can keep going or you can work on something else. But do one of these right away so it gets stuck in your brain.